This video is the first of a series. I anticipate 50 to 60 videos that will cover the expanse of college algebra so that you can look this over either before you take the course and feel like you're, kind of have a basic understanding of everything, or you can use it as a resource in case you just want something phrased a little differently than the teacher that you currently have or the book that you have. Maybe you just want somebody to say it with slightly different words. Okay. Now, in college algebra, you spend a great deal of your time solving for that magic x. What is x? And so we're going to start there. We're going to start talking about equations and solving them. We're going to begin with linear equations. And in order to know what you're going to do when, you really need to look for patterns and decide what you have. And then we're going to try to work really hard in this series to come up with lists, okay? The list of steps of what you do when. You don't keep working, say you had to do problem 14. You don't keep working problem 14 over and over and over. They're not going to give you that problem on the test. So what you do is you develop a list of steps and you memorize that list of steps. And then when you look at something and you go, oh, it's that, I should use this list of steps. That's how you study for algebra or actually any math course. So let's get started and talk about how we tell one from another. So look at this list that I put up here. There's 3. And the first thing you're going to have to decide if it says solve is what you're getting ready to solve linear or nonlinear? And the linear part really has to do with if it's related to a line. Okay, that's where it kind of comes from. So let's look at this first list, and it says linear in one variable. So notice that in this list, I've stuck with x because that's what we're talking about, though they could use any variable like a or y or t, right? But this all has x's in it. So notice that even though you may have x's in 2 places, like here, the one variable isn't talking about it being there one time. They're talking about the only variable in there is an x. Notice that all of these x's, there are no powers, no exponents applied to them, as opposed to this x over here. All right. Now, you may not even be properly prepared for what the power means, and that we're going to talk about a little bit more in a later video. I just need you to know a linear equation when you see one. Okay, so a linear in one variable just has one variable throughout, all x's, all y's, all t's, and there's no powers. So the key is there's no powers. This linear in 2 variables says there'll be 2 variables in there, maybe an x and a y. Typically, these are ones that we would graph when you'd have a line somewhere on your graph. You've probably done that in the past. And then nonlinear is anybody that has powers. Okay. Now, nonlinear has a lot of different ways that you can solve those, and we'll take each one of those individually in later videos. But nonlinear, thank goodness, has one sort of standard list of this is what I'm going to do. And we're going to explore that. And the reason I want to focus on the fact that we're having lists right now is because the single most important thing about these videos is not what I'm writing down. The most important thing is what I'm saying, because what I say is what you have to tell yourself to do so that you can replicate these processes. I mean, have you ever been sitting there listening to your teacher and you're kind of going, yeah, okay, yeah, I got it. Yeah, okay, yeah, I think I can do that. And then you go home and then you're like, I thought I had it. I'm wrong. I didn't have it. All right. And the reason is because most likely you wrote down what they had on the board, but you probably didn't write down what they said. So you can't figure out what they did between each step. So as we go through these videos, the most important thing is what I'm saying. Right. Now, sometimes I tell weirdo jokes or whatever. That's not important. But if I'm saying, okay, we have this, let's do that, let's do this, let's do this over there, those are the things that you need to kind of incorporate into your list. Everybody's list is different. Everybody's list is shorter, longer, more steps. But we'll develop one as we go along. All right, so we're going to focus on linear equations, the one variable ones. So we're going to look at these type right here, right? Now, in order to solve a linear equation, it kind of works like this. Well, let's look at these while we're talking. You simplify the left-hand side, all right? So your equals right here is sort of your middle ground. And over to the left of that would be your left-hand side. And a lot of times it's abbreviated as LHS, left-hand side. Okay, then you have your equals. Then I'm sure you can guess what's on the other side. On the other side is the right-hand side. Often abbreviated as RHS, right-hand side. Okay, so the steps are, oh, it's a linear equation. I should simplify the left-hand side, simplify the right-hand side, then try to get all my variables on one side. It doesn't matter if you get them on the left or the right, but you get them on one side, which is sometimes phrased as isolating the variable. You get your variables on one side, constants to the other side, and then you get a 1x, and I put that in quotes. Like it could be if it's y, you get a 1y, a 1t. So you don't want to know what 3x's are or 5x's are. You want to know what x is, a single x, right? So you're going to simplify the left, simplify the right, get your variables on one side, constants on the other, get a 1x, okay? Now, what is simplify? Okay, simplify means you're going to add like terms or combine like terms. Maybe you're going to subtract or multiply different things and then add or subtract. So just to see what simplify looks like. Okay, if you're going to simplify something and you had something like -4 times 3y minus 4 plus 12y. Notice that this does not have an equals. So they would call this an expression, not an equation. So sort of like a half thought. Okay, so this is an expression, not a complete sentence. Okay, so this is an expression, and the best you could do is to simplify. Now, if like terms, the concept of like terms, are they counting the same thing? Exactly the same thing. So like up here, you cannot add 3x's to x squared because they're close but not exactly the same. In other words, I have 1 x squared and I have 3 x's, but I can't add an x to an x squared. It's like if you worked in a grocery store and you were over in the fruit and vegetable section and your boss said, I want you to take inventory and so I know what kind of apples to order. And you went over there and you just lumped all the apples together and you came back and said, we have 1,142 boxes of apples. Probably not what they wanted. Okay. But if you came back and said, I have 12 boxes of Red Delicious and 10 boxes of Granny Smith and so forth, that's probably what they're wanting of each thing. So I have an x and I have an x squared, and they may be kind of related to each other, like a kind of apple, but they're not the same apple, right? So we would combine like terms. And if that's a little rusty for you, I'm going to make a just-in-time video to talk a little bit more about like terms, and it will be linked in the description. So go down to the description and find the link to a review on like terms. All right, so what do we do here? If you're supposed to start in the middle of the parentheses, remember your rule of order of operations, and I will have a link to a video for rule of order of operations as well. And you say, well, I cannot take 4 away from 3y. They're not like. So what I can do is to multiply. So I can multiply -4 times positive 3y. A negative times a positive is negative. 4 times 3 is 12y. Then you distribute this -4 all the way over to the nether -4, and you'd have plus 16 plus 12y. And so -12y and 12y are counting the same thing. And if you have -12 and add 12 of the same thing, you have none. Or you can think of it as I have 12y and take away 12y, I have no y's left. So the answer to this is just 16. But there's no solving. There's no x equals because it wasn't a complete equation to start with. Let's simplify one more. So if you had simplify 7x plus 3 times x minus 2. Again, there's no equals to another side. Sometimes teachers will put an equals right there. Sometimes even books do that. And it kind of makes people a little crazy, including me. Right? So it's like, it's almost trying like it's tricking you into an equation, but it's not. There is no right-hand side over here. It's not an equation. It's just saying, what is that equal to? Can you clean that up just a little bit? Okay, so 7x plus 3, rule of order of operations. You can't add, okay, like that. You have to start inside the parentheses. Can't take 2 away from an x. You can multiply. So you'd have 7x plus 3 times x is 3x. 3 times -2 is -6. 7x and 3x are like terms. They're counting the same thing. They're counting x's. So if I have 7 of them and 3 more, I have 10 of them now. And I can't take 6 ones away from 10 x's. So these would be your answers for these two. So I hope that kind of helps you to remember how simplification goes. Remember that in the description there'll be a link to rule of order operations and also to like terms. So here we go. Let's say that we have an equation, and when there's an equation, they won't say simplify. The instructions would be to solve. Okay, so to have an equation, I have a left-hand side and I have a right-hand side and an equals in between. Now, according to what I told you, right, so the list, okay, when they ask you to solve, what you need to do is you look at it and you say, is it nonlinear or is it linear? Now, we haven't done any nonlinear yet, okay, but I look at it and go, I don't see any powers. That's the thing that makes it nonlinear. Okay, the powers are the little numbers written just above and to the right of the variable. So this is linear. Now, how do you do linear? You simplify, and I'm going to abbreviate the left-hand side. Then you simplify the right-hand side. Then, now there's kind of longer ways to say this. You get your variables on one side, your constants on the other, okay, because if it doesn't have a variable, it's a constant. So or you can just say you isolate your variables. That's actually the fast way to do it, is to say isolate your variables, which means if it's isolated, it's by itself, which implies the constants are on the other, but we're not going to do it quite that quickly. So you get variables on one side, if they're not already. Doesn't matter if it's left or right. And constants on the other. And then you get a 1x. And again, this could be a 1y, 1t, or whatever. You just try, what you're trying to get is x equals with an implied 1 right there. So you're trying to get x equals. And then you should check your answers. The nice thing about equations is you can check your answer before the teacher checks your answer. So all you have to do is substitute that number back in to the original equation and see if it turns out to be a true statement. All right? I always tease my class and say, if you're solving an equation and your answer's wrong, I always feel like I should take off twice. Okay, once because it's wrong, and the second time because you didn't check it and figure it out before you turned it in. I don't actually do that. But I tease them about it and go, if you have a way to check your work before your teacher does, you should do that when you can if you have time. All right, so here we go. Let's see if that list is going to work over here. So I have an equation, it says solve, and to the front of my mind comes this list of steps. Okay, yes, is it linear or nonlinear? Okay, I don't see any powers, it's linear. So I simplify the left-hand side. And remember, simplify says we're going to try to see if there's any like terms we can combine. Simplify. So 4x and x are like. And like is sort of a misnomer because you know, it's not kind of sort of alike. I can't add an x to an x squared. They're kind of alike. Like actually means you're counting the exact same thing. Okay, so if I'm counting 4 x's and somebody gives me one more x, I have 5 x's. 3 is not counting the same thing, and 6 plus 1 are counting the same thing. They're like, and 6 and 1 are 7. All right, so I simplified the left, I simplified the right. I get my x's on one side. Well, all my x's are on the left, so let's keep them there. Let's not do any unnecessary work. And let's put our constants on the other. How do you move things? Well, to get rid of something or to move it to the other side, you do the opposite of what it's currently doing. So since I don't want the negative 3, or you can think of it as subtracting 3, the opposite of that is a plus 3. So what I'm going to do is to add 3 here, and you have to add the same thing to the other side to be legal. Remember, it's kind of like the scales of justice, where they're like this. And so if you put 3 on this side, you have to put 3 on this side so they go back to even. All right. So minus 3 plus 3 is 0. So we have 5x equals, and 7 plus 3 is 10. Now, my goal is to get down here to x equals. So I don't want the 5. So what is the 5 currently doing? It's multiplying. What's the opposite of to multiply? You would divide. So dividing both sides by 5, 10 divided by 5 is 2. All right. So I simplified the left-hand side, simplified the right-hand side, got my variables on one side, constants on the other. I got a 1x, and I'm going to check. Now, you could check up into here, but if you check into that second step, it just says you're right from the second step on. Have you ever made a mistake between the first and the second step? If so, you can't do that. Okay. So if you want to know if you're right from the beginning, you check it into the first step before you did anything to it. Okay, so does 4 times 2 minus 3 plus 2, does that, there's a little question mark, does that equal 6 plus 1? This is supposed to be a very badly shaped question mark. 4 times 2 is 8, minus 3 plus 2, is that equal to 7? Okay, 8 minus 3 is 5 plus 2, yep, that is a true statement. If that becomes a true statement, then you know that you are right before your teacher gets to it. All right? Now, what you do when you're studying is you listen to the teacher, you get this list, you write it down as best you can while you're listening to your teacher, and then you go, or maybe you're reading a book, okay, so make a list, and then you try some problems, okay, to see if your list is robust. If you forget something or make a mistake, then you come back over to this list, and you might add another step in there that says, I don't know, watch your signs, okay, don't drop your negatives, be careful, some sort of note to yourself, okay, every time you forget something, you make another note. All right, let's try another one. Okay, let's try 7x plus 3x minus 2. Once you've done a couple of easy ones, a couple of middle ones, and a couple of hard ones. And if you can do them all in a row correctly, move on to another topic. You've got this down. Okay? But just don't do the little ones and not do the harder ones. And don't do the same problem over and over. It's not going to help you recognize these things. So somebody's going to say solve, and you go, oh, solve. Okay, I can check my answers. Solve says, what is it? Is it linear or nonlinear? I don't see any powers, so it's linear. So I have my list. Simplify the left, simplify the right-hand side, get your variables on one side, constants on the other, get a 1x, 1y, whatever, and then check if you can. So you would go, well, I can't add 7x's to 3. I start right here, and I'm going to multiply to get that parentheses out. So 7x plus 3x minus 6 equals 4. 7x and 3x are like. So this is 10x minus 6 equals 4. Now, now I'm going to get my variables on one side, my constants on the other, so I need to move the 6. What's the opposite of to subtract 6 or a negative 6? It's a plus 6. So 10x is equal to 10. Now I want a 1x. This 10 is currently multiplying, so I divide. So x is 1. Now, you can go back up to here and check it. It does 7 times 1 plus 3 times 1 minus 2 equal 4. So 7 plus 3 times negative 1 does 7 minus 3 equal 4? Yes, it does. All right, so I'm ready to box this in. All right, let's try one that looks like this. What if it's minus 4x is equal to 5 times 1 minus x over 6? Again, it would say solve. And you go, well, it's got fractions in it, but there's no powers, so this is linear. And you would say, well, I want to simplify both sides. So can I do anything on the left-hand side to simplify minus 4x? Nope, that's about as simple as it can get, right? Can I simplify anything on the right side? Well, you can multiply this 5. And you would have 5 minus 5x over 6. Now, this is one of the things that you might want to add into your list. Some people just kind of recognize it and mentally add it in, but you may want to physically write it into your list here. All right, so somewhere right in here, you could add a little note that says, if you have fractions in this equation, and some people write it in up here, it's wherever you think you need to remember to do this, all right? You can multiply both sides of an equation by anything you want. So if you multiply both sides by a judicious use of the least common denominator, you can clear these fractions, all right? So you might want to write a note that says, if you have fractions, okay, multiply both sides by the least common denominator. All right, same thing on both sides. You can't say, I'm going to multiply one side by 12 and the other side by 4. So let's look right here. What is the least common denominator? Well, negative 4x is over 1, and this is over 6. So 6 would be my denominator. So I'm going to multiply both sides by 6. Even if it doesn't have a denominator, what you multiply one side by, because of this denominator on the right, you have to multiply the other side to be legal. Now, the beauty of this is this 6 is going to cancel into that 6. Now, let's talk about the word cancel. I used to be department chair and dean. I had teachers that word for me that if you said the word cancel, They'd all but throw up. All right. So, in honor of those teachers, cancel may not be the most appropriate word. You're supposed to say it reduces or they divide to one, right? But a lot of people just in general say cancel. But if your teacher is one of those who goes like that when you say cancel, then you should say reduce or simplify. All right. Now, so this 6 and this 6 reduce to 1. Okay, 6 over 6 is 1. So let's see what we've got left. So 6 times a negative 4x is a negative 24x equals. And since these 6's are now gone, we'd have 5 minus 5x. Well, I've simplified as best I can, both sides. Now I need to get my variables on one side and my constants on the other. Now it doesn't matter if your variables are on the left or on the right. I think the majority of the students I've had, they just feel more comfortable with the variables being on the left. So let's try that. All right. So I have minus 5x, so the opposite of that is to add 5x to both sides. So negative 24x plus 5x is negative 19x. And these are gone, and you have 5. Now, I don't want to know what negative 19x's are. I want to know what 1x is. I want to know what one of them is worth. So negative 19 is multiplying. The opposite of multiplying is to divide. So x is negative 5 over 19. Now, let's talk some little details here. Let's talk about 5 divided by a negative 19. All right. Technically, it is not quite finished if you leave your answer that way, because what you're saying is I have a positive 5 divided by a negative 19. And a positive 5 divided by a negative 19 is a negative number altogether. So these two, positive divided by a negative, is a negative. The whole thing's a negative. So leaving a sign in a fraction like that is considered not quite finished, and so most likely your teacher would count off. All right. Now, can you check these? You bet. Now I'm just going to do this really quickly just to show you that even if you don't like the number, you can do it. But this is probably the last one I'm going to check. Maybe one more. All right. And what we want to do is to check it into the original equation, not after you played with it, right? Now, so here I've got this set up. So negative 4 times negative 5 over, and I'm trying to see if this is equal, would be a positive 20/19. So I'm going to multiply this 5 out. And I would have 5 times 1 is 5. A negative times a negative is a positive. And 5 times 5 is 25/19 over 6. Now, remember how in the equations we multiplied both sides? Like over here, we multiplied both sides by 6. Well, when you have a fraction like 25/19, remember in elementary school, maybe into junior high, you would learn that, let's do 3/4, so it's not the same number. You could multiply the top by anything you wanted as long as you multiplied the bottom by the same thing, because then you are in effect multiplying by 1, right? 2 over 2 is 1. So this right here is a large fraction, where the top, this is complex fraction is what it actually is, where the top is 5 plus 25 over 19 over 6 over 1. So these are technically over 1. And one of the techniques you could use to clean this up is if I multiply the top of this by 19, that's going to affect this 19. And that's only legal if I multiply the bottom by 19. Now what's going on top of there is that this 19 has to multiply here and here, because you can't multiply part of the top of a fraction. You have to multiply all of the top of a fraction. So here we go. So this would be 20 over 19. and you would have 5 times 19 plus, and this 19 and this 19 are going to cancel, leaving you 25 over 6 times 19. And some people want to cancel out these two 19s, but you cannot, because these are not multiplying in the numerator. There's this lovely plus sign that makes it a binomial, and you cannot cancel those 19s, no matter how tempting that is. So this would be 95 plus 25 over 6 times 19. I'm going to clean that up in a minute. So 95 and 25 are 120. Now, see how in the numerator you just have one term? So this 6 can divide into 120 20 times, right? So this will leave you 20 over 19 and 20 over 19. And so this is true. So your answer is correct. Now, maybe if you had a test that had 30 problems on it and you're going, okay, what, 3 points apiece? I've got to get 30 problems done. I don't have time to check each one. But if this was the only question on your test or one of 2 questions on a quiz, it would be worth 50 points to me to go over and check this. So you should know how to do that. Now, let's try another one. Here's an equation. It would say solve. It has fractions in it. So I need to find what would be like the least common denominator. Some of your teachers may call it the least common multiple, but it's the same process as finding the least common denominator, add fractions together. And we're going to use this in a more complicated procedure later on. So I want to break down how you do this. So what you do is you think of 15 and you would say, what are the factors of 15 that are prime, that don't break down any farther? Well, 3 times 5 makes 15. Then you would look at 9, because this is 3 times 5. And 9 is 3 times 3, right? So you would look at this 3 times 3 and look at your least common denominator and say, do I already have a 3? Yes, I do. All right. Do I have a second 3? No, I do not. So I need a second 3 to have all the pieces and parts from your denominators. And 3 times 5 is 15 times 3 is 45. Some of you are really comfortable with numbers and playing with them, so you may have already found 45, but if not, this is a way to do it. If you need more help finding least common denominators, write me a note in the comment section and I'll make a video on how to find common denominators that are the more complicated kinds. So what I'm going to do is to multiply both sides by this least common denominator. So this 15 goes into 45 3 times. And this 45 only multiplies this first number. It's not going to multiply over here because there's not a plus or minus right here. You have to have a plus or minus right there to be a distributive property. So you're just going to multiply times this near neighbor number and be done. So this is 3. Now because of this plus right here, we're going to come back with the distributive property for that one single number in just a minute. And 9 goes into 45 5 times. So you have 5 times x plus 2. I could make a bigger 5. There we go. Now, so 3 times 2x is 6x. 3 times 5 is 15. 5 times x is 5x. 5 times 2 is 10. So you want your x's on one side, your numbers on the other, because we've simplified both sides. I'm going to do the left, so I would subtract. I don't want them on the right. So to get rid of them on the right, these 5x's are understood to be a plus 5x, so I'm going to subtract 5x. And what I do to one side, I do to the other. So we would have x plus 15 equals 10. Now, if I want my x's on the left, I do not want the constants there. So what's the opposite of plus 15? Minus 15. So x, these cancel. 10 minus 15 is minus 5, and that's your solution. Now, some of your teachers may not have you do x is equal to negative 5. They may have had you do, I'm not any good at drawing a curly brace, negative 5. This would be the solution set. So depending on how your teacher wants it expressed, these two things are actually equivalent. I actually like this one better because it started off with the variable, and I kind of like seeing the variable, but every teacher has things that they like and don't like. So the one with the red pen wins. So if your computer wants it entered a certain way or your teacher wants it a certain way, that's the way you do it. Let's do one more. You'll see this process again later. So this one, I'm just changing out the X for an A just for something different to do. And it's already simplified on the left, and it's already simplified on the right. There's nothing I can do. But I want, and I've got my variables on one side, my constants on the other, and I want an A, an understood 1A. And right up until now, we've been dividing because negative 3/4 is multiplying. And so the opposite of to multiply is to divide. And sure enough, this would get you 1, anything divided by itself, right? But there's another way to get a 1, and I just want to show this to you because sometimes it comes in really helpful. It just saves you one step, okay? It saves you one step. But it's a step that if you didn't have to use, every step counts. What's another way to get a 1? Okay, something divided by itself is 1, right? But something times its reciprocal is also 1. And the reciprocal is itself turned upside down, right? The reciprocal of 2/3 is 3/2. And this is 6/6, which is 1. So what's the reciprocal of negative 3/4? The reciprocal of negative 3/4 is negative 4/3. And I would divide or multiply both sides by negative 4/3. So what do we have here? These 3's cancel, these 4's cancel. Negative times a negative is a positive, so that gives you your 1A. Or you can think of it as 12/12A, because a negative times a negative is a positive. And this would be negative 4 times 5 is 20. 3 times 6 is 18. And you could reduce that, or you could say there's a 2 in common between the 4 and the 6, and reduce it up here or down here, and you would have negative 10/9. So you can, if you have a fraction, it might save you a step if you multiply by its reciprocal and not divide by that. Okay, because if you had 5/6 and you divided it by negative 3/4, this would be 5/6 divided by negative 3/4. 5/6, you change this to a times, multiply by the reciprocal, and now you're here. So it saves you this. All right. Now, all of the equations that we have solved so far are called conditional. These have all been conditional equations, which say they're true if the conditions are right. Okay, and the conditions are right is it's a true statement if A is equal to negative 10/9. It's a true statement if X is equal to negative 5. It's a true statement if X is equal to negative 5/19, and so forth. It's true only under certain conditions, which is for that one number, right? So if it's true for one number, it's called a conditional statement. There are some that are called identities. Which means they're true all the time. You'll hear a lot more about identities if your next class is going to be trig. Now, So let's try one. And so we have 4 times 2x plus 7 equals 2x plus 19 plus 3 times 2x plus 3. Now, you wouldn't know it was an identity to start. Somebody would say solve, and you would be doing your list. Simplify the left. Oh, okay. So I can't add 7 to 2x's. So 4 times 2x is 8x. 4 times 7 is 28. Remember, I'm going to have a link to the rule of order of operations and a link to like terms in the description. All right. Now, the right is very complicated. Okay, so let's see. Let's start with the parentheses. I can't add 3 to 2x's. I can multiply by 3. So I'd have 2x plus 19, which are not like, plus 3 times 2x is 6x. 3 times 3 is 9. So still working on the right. 2x's and 6x's are 8x's. They're like terms. And 19 and 9 are 28. So 8x plus 28 is, yeah, 8x plus 28. So right here, you can tell that no matter what x you put in there, it's going to make a true statement. If you said x was 1, you would say, well, 8 times 1 plus 28, is that equal to 8 times 1 plus 28? Okay. What about negative 2? Sure, no matter what number you put in here, this side's going to equal that side because it's the same process. So you can tell right at this point that it's going to be true for any number of x that you put in there. Some people want you to go farther. So you would say, all right, let's put my x's on the left. Well, you would subtract them from this side because they're an understood positive. So you would subtract from this side. These are zeroed out, as are these. And you have 28 equals to 28, which is also always true. Isn't 28 always equal to 28? But then again, some teachers want you to go farther. And you would end up with 0 is equal to 0, which is also always true. All right, so if you end up with a statement where all of your variables have fallen out, right, down here, and the resulting statement is true, this is an identity. It's always true. Or you could have told it from right here. If they're an exact match on both sides, exactly no signs are different, no numbers are different, it's a true statement always. This is called an identity. And there are several ways you can answer this question. One way would be all real numbers, meaning any real number that you want to use will give you a true statement. Some books and some teachers have you use this kind of double vertical line with this R through it, which symbolize all real numbers. Okay, some have you do interval notation, which is negative infinity to infinity. And some have you put them in the set builder notation. And hopefully your teacher or your book has demonstrated one of these and you'll do whatever they ask. Works for me. But all of those are true. Now, I have to admit that these are the ones that I don't like because I can't check these, okay? There's no way to take a number necessarily and put it back in there and make sure I didn't drop something, all right? So I double and triple check my additions and my negatives and everything just to make sure. Now, what does a contradiction look like? Because if you have an identity that's always true, you probably have some case where it's never true, all right? And those are called a contradiction. All right. So what if you have 1/2 6x plus 10 equals x plus 2 times x plus 5? Now, you remember if we look at it and go, oh, I have a fraction and I don't care for them, you could actually multiply both sides by 2. Or in this case, since 6x and 10 are both something that 2 will go into, you can just multiply it as it sits. It would be totally your choice. So 1/2 of 6 is 3x. 1/2 of 10 is 5. And this would be x plus 2 times x is 2x. 2 times 5 is 10. Three x plus 5 is equal to, because I can't add 5 to 3x, x plus 2x is 3x. If I try to get my variables on one side and subtract 3x from both sides, I'd have 5 is equal to 10, which is never true. All right? So if this is never true, there is no number that you can substitute in for x to get a true statement. So never true. How does that look like for an answer? You would write, there is no solution. That's one possibility. Now, in order to not have to actually write words, there's a symbol for that, and it's 0 with a slash through it. So if you've been in the military or you're used to making your zeros that way, or you're a computer programmer who also make their zeros that way, Europeans, different people make their zeros that way, be careful, because if the answer is actually 0 and you do this, you're saying empty set. So this symbol right here in a math class is not 0. All right, be careful. Don't use that 0 with a slash through it for 0. You'll get points taken off. All right, because in math class, 0 with a slash through it says empty set. It doesn't say I have 0. It says there is no answer at all. Okay, it's like if I have a purse, all right, and I say I have no money in my purse, the amount of money I have is 0. Empty set says I don't even have a purse. All right. So empty set not equivalent to 0. Don't use that unless you mean it. Sometimes they'll have you do this set builder where it's just blank. Okay. All right. And once in a great while, I have seen teachers have you do this, which just makes me kind of makes the hair on the back of my neck kind of stand up. All right. Like, how can you have a set that's an empty set? All right. But, so that one just sort of creeps me out. So what kind of answers can you get? You can get a conditional answer where you have x is equal to some number, which you can check all those. Okay. You can get an identity which says the left-hand side is always equal to the right-hand side. And the way to say all numbers would work is all real numbers. Sometimes shown with this R. Or you can have a contradiction, which is never true, and it would be no solution. Or empty set, a 0 with a slash through it. All right. Now, in the description, there's going to be a link to practice problems. And on the first page is the practice problem assignments. It's usually like 5 to 10 problems on each video. And if you go on down past that, I will have worked the problems out, and then you can compare your solutions to my solutions. All right? But the thing to take away from this lecture, right, is when somebody asks you to solve, you have to decide if it's linear, this is what you memorized, or nonlinear. Okay? If it's linear and you go down this way, you simplify the left-hand side. Then you simplify the right-hand side. Then you get your variables on one side. constants on the other. And then you multiply or divide to get a 1x, 1y, 1t, 1 whatever, and then you really should check your answers, okay? But you might want to add these two things down in here to say what happens if you get a true statement or a false statement, all right? Also in the description is going to be a link to the next video, which is going to be applications of linear equations, otherwise everybody's favorite topic, which is story problems. Okay, I'll say that because students always would go, "Ah." All right. So I never got the impression that it was their favorite topic in life. So the next video is going to be story problems, and I hope to see you at the next video.